Hello, 5th and 6th grade scientists. So you're going to need your lab sheet in order to fill out the conclusion, and we're going to do some talking about what happened in the lab yesterday. All right, so our original question is, can I change the freezing point of water? So we're going to start evaluating and concluding what we learned yesterday. Did the ice melt faster in the plain cup of ice or in the cup with ice and salt? Well, we noticed that as we were observing every 5 minutes, we noticed that there was more water in the bottom of the cup with ice and salt than there was just plain ice. So we can conclude that the ice melted faster with the salt in it. Why? Because it changed the freezing point of water. Okay, so our question, can I change the freezing point of water? And we will get back to this on why this happens. Okay, so yes, did our hypothesis match what happened? So you're going to have to revisit your hypothesis and tell whether it happened the way you thought it would or whether something different happened. And I want an explanation why or why not. Okay, all right, so independent variable causes change. Dependent variables are what changes. So what changed in the experiment? Well, obviously, the ice changed. So what was the independent variable? Well, the independent variable then was the salt. All right, now we've got some information here. So we learned that the freezing point of water is 0 degrees Celsius or 32 degrees Fahrenheit. However, the freezing point of water can be lowered by adding salt to the water. With the salt added, the water will no longer freeze or stay frozen at 0 degrees Celsius. Thus, the ice will begin to melt back into liquid form. Melting is a change in state from a solid to a liquid. It is the opposite of freezing. So keep in mind that salt can only lower the freezing point of water by a certain amount, and this amount depends on how much salt is used. If the temperature is extremely cold, such as 20 degrees Celsius, negative 20 degrees Celsius, or 0 degrees Fahrenheit, the ice will not melt and the water will stay frozen or still freeze even if the salt is present. Okay, so we noticed also that there was ice on the outside of the cup. So the water, the condensation that formed on the outside of the cup and the ice that was hitting up against the cup made it so that it was cold enough to create those ice crystals on the outside of the cup. And that was pretty cool too. So what is a real life application for this? Snow days, right? Okay, so when it snows or when there's ice out on the road, you'll notice that there are the big trucks that go out and spread the salt out, and also they scrape the ground to try to get that snow and ice away from the roads so that we can go to school, or so that you will have safe roads to travel to wherever you're going. Okay, so and we also notice that people will go to stores and buy containers of salt to spread on their sidewalks or on their porches so that the mailman can get up and deliver the mail on your porch. Also on your driveway, so you can safely get out of your driveway. But on the flip side of that, if it's below a certain temperature, the salt won't work. So when the salt doesn't work, what do we get? A snow day. All right. So does it have any bearing on our lives? Absolutely. Because every once in a while, we kind of need that snow day to rest, but we don't want too many of them. All right. So can I change the freezing point of water? Yes, by adding salt. And remember, salt only changes the freezing point of water to a certain degree. And when the temperature gets low enough, the salt can't change the freezing point of water anymore. Okay? All right. So I hope you will try this at home. And I need you to fill out your lab sheet. And then I need you to upload that. That is for a grade. All right? I want you to keep thinking. Keep watching, always stay curious, and I will see you tomorrow.